Okay, welcome students to 6.4. So the equations in section 6. This section contain inverse trig functions. So we continue to use the definition of inverse trig functions and solve by undoing. When the equation contains two inverse trig functions, we use a dummy variable to represent one of them. Okay, so because they're inverse trig functions, they're only going to have one solution. So keep that in mind. Okay, so the range of this will only have one solution. Okay, the value for the x. Okay, not like the two solutions we had before, or multiple solutions. We only have one solution. Okay, so let's solve. Let's divide by 3, and I get the inverse tangent of x is equal to pi over 3. Okay. So we want the tangent whose angle is pi over 3. So x is equal to that angle. X is equal to the tangent of pi over 3. Okay, well, what's the tangent of pi over 3? Well, pi over 3 on the unit circle. Okay, the y value is radical 3 over 2, and the x value is 1/2. That's 2, by the way. Okay, and the x value is 1/2. And so the tangent of this is going to be radical 3 1/2, radical 3 over 2 over 1/2. So again, this is the y over the x, right? So x is equal to radical 3 over 2 over 1/2. The 2's are going to cancel. Radical 3 divided by 1 is just radical 3. And so x is equal to radical 3. Okay, part B. The secant of x is equal to the cosecant of 2. Now, this guy here is an angle. We'll call that angle theta. Okay, so it's the angle whose secant is x. That's what this means, inverse secant of x. The angle whose secant is x, right? Or we could say the secant of theta is equal to x. Okay, so we're going to use that value there. Okay, so we're going to replace that with theta, and we're going to solve for theta, and then we're going to go back and solve for x. Okay, so we're going to say that theta, because this has two inverse trig functions, we're going to use theta as our dummy variable. Theta is equal to the cosecant, inverse cosecant of 2. Okay, so cosecant of theta is equal to 2. Okay, so that means, well, what's cosecant? Cosecant is sine, is 1 over sine theta. So 1 over sine theta is equal to 2. Okay, so doing a little bit of algebraic manipulation, if I put this 2 over 1 and then I flip everything upside down, I get sine of theta is equal to 1/2. Oh, okay. Okay, so where is the sine of theta equal to 1/2 here? Okay, sine of theta is equal to 1/2. Okay, yeah, on the unit circle, the sine of theta is equal to 1/2. Okay, it is equal to 1/2 at 30 degrees. Okay, and at 150 degrees. Okay, so theta is equal to 30 degrees, 150 degrees, okay, and then so forth and so on, and every 2 pi then on. Okay, so we know that the 30 degrees, the 150 degrees, okay, but now what we want is we want the secant, right? We want the secant of theta here. Okay, so what's the secant of theta? Okay, so the secant of theta is equal to x. Okay, so let's look at our triangle here. Okay, if we have 1/2 here and we have here we're going to have radical 3 over 2, okay, at 30 degrees. Okay, and so what's secant? Secant is 1 over cosine, right? So 1 over cosine theta is equal to x. Okay, and so if I let this be a positive radical 3 over 2, at 150 would be a negative radical 3 over 2. So I could actually write this as plus or minus 1 over radical 3 over 2 is equal to x. Okay. Or I could say that x is equal to plus or minus dividing by a fraction multiplied by the reciprocal is 2 over radical 3. If I wanted to rationalize the denominator, I could say x is equal to plus or minus 2 radical 3 over 3. Okay. Now, I just want to make sure that this works. Okay, so I'm gonna check both of these solutions with my calculator because one may work and one may not. It depends on the sign of everything. Okay, so let's see if we can get this to reconcile. So let's go to the calculator, and we're going to say that the secant, which is the 1 over the secant inverse, which is the inverse cosine of the reciprocal. So secant inverse cosine of the reciprocal, so of 1 over 2 times radical 3 over 3. Okay, so that's the inverse secant, and they're saying that that should equal. Let's find out what that equals. That equals 0.52, and they're saying that that should equal the inverse cosecant of 2. Okay, so the inverse cosecant is the inverse sine of the reciprocal of 2, which is 1/2. And they do equal. Okay, now let's try this with if it was negative inside, would it still work? If this was a negative, okay, second, not answer. I want insert, second insert. I want a negative 2. Delete. There we go. And what does that? That gives me a different value. Okay, so the negative doesn't work there. Okay, because it's going to give me a different value. So we can cross off the negative value there. So when we check it, we only get the positive value to work. Okay, the negative value doesn't work because we're taking inverses. Okay, our original values were inverses. So when we go back to this, the 150 isn't a solution. Okay, it's only that first value for 30 because that the inverse cosecant of that is equal to 2. Okay, so I guess the for 150 it would not be the same thing. So it doesn't quite work. Okay. Okay, let's go on to the next one. Okay, arc cosine of x minus arc sine of x is equal to pi. So arc cosine, okay, inverse cosine of x minus inverse sine of x is equal to pi. Okay, so I'm going to let the inverse sine be equal to theta. Okay, so the sine of theta is equal to x. Okay, so that tells me that the inverse cosine of x minus theta is equal to pi. So what I'm going to do is I'm going to add theta both sides. Okay, so inverse cosine x is equal to theta plus pi. Okay. Theta plus pi. This tells me that the x is equal to the cosine of theta plus pi. Okay, plus 180 degrees. Okay. So what I can do here now is I can use a sum to product formula. I could say, well, x is equal to cosine theta cosine pi minus sine theta sine pi. Okay. But what is the cosine of pi? Cosine of pi, -1. What's the sine of pi? It's 0. So this whole thing goes to 0. This goes away. And this becomes negative cosine. So x is equal to negative cosine of theta. Oh, okay. Okay. But what was theta? Theta was the inverse sine of x. So x is equal to the negative cosine of the inverse sine of x. That's interesting. Whoops. Sorry about that. I don't know why that closed out. Let's bring it back. Okay, so inverse sine of x, right? So x is equal to the negative cosine of the inverse sine of x. Okay, so let's look at a triangle here. So we know that the sine of theta is equal to x. Okay, so sine of theta is equal to x. So if this is theta, then the sine is going to be opposite over hypotenuse. So the sine of theta is equal to x. Okay. Sine of theta is equal to x. But the cosine of theta is equal to negative x. Cosine of theta is equal to negative. That's interesting. Okay, cosine of theta is equal to negative x. Sine of theta is equal to x. Cosine of theta is equal to negative x. Okay. Well, let's just deal with this guy first. Okay, so this guy is going to be using the Pythagorean theorem. This is going to be opposite over hypotenuse, and then this is going to be the square root of 1 minus x squared. Okay, right there. Okay, so the cosine, okay, so I'm not going to do that. That's making things too. We'll deal with that later. Okay, so the cosine is going to be what? The cosine is going to be the square root of 1 minus x squared. So x equals negative square root of 1 minus x squared all over 1. Okay, so this is going to be x is equal to negative square of 1 minus x squared. Okay, so then if I square both sides, I get x squared equals 1 minus x squared. So 2x squared is equal to 1. Divide by 2, x squared equals 1/2. Okay, take the square root of both sides. X equals plus or minus radical 2 over 2. Okay. Plus or minus radical 2 over 2. Because it would be 1 over radical 2, but then I rationalized the denominator. Okay, radical 2 over 2. Okay, so now I need to see, well, are both of those going to work? Okay. And if not, which one doesn't work? Okay, so, oh my gosh, this keeps messing up. Okay, so let's plug this into the calculator and see if it gives me pi units here. So again, let's see. What is the arc cosine? What angle gives me the cosine of what angle gives me radical 2 over 2? So the cosine is radical 2 over 2 at pi over 4 or 7 pi over 4. Okay. The arc sine is, okay, the arc sine is plus or minus radical 2 over 2 at so at 3 pi over 4. Okay, so this is the cosine is positive here. Cosine's negative over here, and vice versa for sine. Okay, so we're really going to be dealing with kind of these four. Let's just deal with one at a time because it's going to get messy. Okay, if I take radical 2 over 2, okay, x equals radical 2 over 2. Okay, the arc cosine of radical 2 over 2 is pi over 4. Okay, the arc sine of radical 2 over 2 is pi over 4. If I were to subtract the two of those, I would get 0. So that doesn't work. Okay, so the positive is not going to work there. What about the negative? Does the negative work? Does the negative radical 2 over 2 work? Well, what's the, let me erase this. What's the arc cosine of negative radical 2 over 2? Well, that's going to be second quadrant, which is going to be that 3 pi over 4. What's the arc sine of negative radical 2 over 2? Well, that's going to be fourth quadrant, which is, we'll call it negative pi over 4. Okay, we could call it 7 pi over 4 if we wanted to. If we want, but I'm going to call it negative pi over 4. Because when we subtract these two, okay, when I subtract these two, that means that I add pi over 4, and that becomes 3 pi over 4 plus pi over 4, which is 4 pi over 4, which is pi. So that does check. So this works. And again, if I were to plug that in, oops, if I were to plug this into a calculator, I would, with the negative, it should work. That I get pi out. So let's do that. Make sure that it's in radian mode first. Okay, it is. Second quit. Okay, and we want to say, well, what's the inverse cosine? Inverse cosine of negative radical 2 over 2, negative radical 2 over 2. Okay, minus the inverse cosine, or sorry, the inverse sine of negative radical 2 over 2. And that's 3.14159, which is pi. So that does check, which is great. Okay. Okay, let's go over the last example here for this section. Okay, solve for x, where x is restricted to negative pi over 6 and pi over 6. Okay, so we know that x is restricted to basically 30 degrees and negative 30 degrees. Okay, we can only have, oh no, those are the x's, sorry. X is restricted to, not the angles. X is restricted to negative pi over 6 and pi over 6. That's what they're saying for this value. Okay, so solve for x here. Okay, so X is within this domain. So let's divide by 4. Okay, so we get divide by 4. We get the tangent of 3x is equal to y over 4. Okay. Okay. And so the inverse tangent, so 3x is equal to the inverse tangent of y over 4. Now, what's the domain on this thing? The domain on this thing, okay, or the range, I guess I should say, the output of that goes from negative pi over 2 to pi over 2. So that's why they restricted x to that domain, because the inverse tangent has pi over 2. And then, right, and then if we were to divide by 3, okay, 3x equals this thing. It goes from negative pi over 2 to pi over 2. But then if we're to divide by 3, it would go to negative pi over 6 to pi over 6. Okay. X goes from negative pi over 6 to pi over 6. Now, okay, we were just checking the domain on that. But going back to this guy here, okay, we have 3x is equal to inverse tangent of y over 4. Just multiply 3 by 1/3. And we get x equals 1/3 inverse tangent of y over 4. Okay. And that's it. That's all for x. Okay, that is chapter 6. Good luck on your quiz and exam, and I will see you in the next chapter.